Yeah, so permutation combination is all about knowing order of things. Okay, so I'll give you an example. Let's suppose you're having a fruit salad and you have what uh, a number of fruits in it, maybe some grapes, some apples, some bananas. अब उन चीजों के ऑर्डर से फर्क नहीं पड़ता है, लाइक यू जस्ट सी देम एंड यू लाइक ओके एप्पल पहले आ जाए या ग्रेप्स पहले आ जाए, कोई फर्क नहीं पड़ता है उससे. बट what matters is how many things there are, right? But think of, let's suppose you want to use you want to open a safe or a combination lock. Now combination locks, they usually depend on a certain number, and you can't be like, okay, if the number is, let's say, 786, you can't be like, okay, I'll try 687 and it should open up, because the order of numbers is different. So order of numbers, when that matters, we call it permutations. So maybe they should call it permutation lock instead of combination lock. Khair, I'm just kidding. Yeah, so permutations are when order matters, and combination is when order does not matter. Okay, so for example, you want to get 3 scoops of ice cream, so you can have chocolate, vanilla, and strawberry. So if you're not very finicky about it, you can be like, okay, I can have them in any order. So that's combination, that you are getting 3 flavors and you're getting chocolate, vanilla, and I don't know, strawberry. But let's suppose you are somebody who prefers to have, let's say, chocolate at the end. Then now you have changed the order and you have specified the order in a way. So now order of things matters. If chocolate comes first, that is not the same as chocolate coming at the end. The experience is different. And that is why that will be a permutation. Mathematically, it's a permutation, not a combination. Okay? So when the order matters, it's permutation. When the order does not matter, it's combination. And you can think of it as permutation is an ordered combination, if you want to. All right. So there are 4 basic cases. But before we get into that, let's just think about permutation first. Permutation is when you're arranging things in some specific order. For example, there are a few people participating in a competition. You want to pick the first, the second, and the third. So obviously the order matters there. The person who comes first is not the same as the person who comes second. The feelings and everything else involved is different. But if you're just picking maybe the best 3 people out of anything, and the order doesn't matter, in that case, it will be a combination problem then. So the key difference whenever you're solving these questions is, the key point is understanding what is a permutation and whether it's a combination. Okay. And for that, you have to understand that order is what matters. Order is what determines this. Now, the basic case is when you have permutations and you are allowed to repeat things. So, for example, you are picking, I don't know, 3 things out of 10 things, and you can just pick any of them at the same time. So, what we usually do is we think of this as a slot method. You're picking 3 things out of 10 things. So, we think that, okay, I have 3 slots to fill basically. In the first slot, I can pick any of the 10 things. So I'll be like, okay, I have 10 different options. In the second slot, if repetition is allowed, if you are allowed to pick the second thing again, the same thing twice, you can be like, okay, now I have 10 options again. So that is 10. And for the third time, if you're going to pick something and you're like, okay, I still pick this one, and you're allowed to do that, then this is again 10. 10 is your number of options that you have. Different ways in which you can pick stuff up. Okay. So in this case, it's going to be 10 times 10 times 10, which is basically 10 power 3. So we can think of this as n was the number of things that you were picking from, and r was the number of times you were picking things for. And because you were allowed to repeat, it simply becomes n power r. So if you want to pick or permute r things out of n things, and you're allowed to repeat, the simplest case is you simply multiply this or you apply n power r. Now that is permutation with repetition. Now let's say you are not allowed to repeat. Let's suppose you are picking, as I said, 3 winners for a competition. Then let's suppose 16 people are participating in that. In that case, when you're picking somebody up, we can still use the slot method, but this will basically be right. That okay, in the first case, I have 16 different people to choose from. But in the second case, because I have already chosen a winner, I don't have 16 people to choose from. I can't pick that person again. So now I have just 15 options. And once I pick the 15th one, now I pick 2 people out of 16. I'm left with 14 different options. So that is 14. And now your possible different permutations are 16 times 15 times 14. Whatever that number is. Okay. So what matters is that over here, you are basically, I'll just multiply them so you get the numbers. Yeah. So 3,360 different ways of picking 3 winners out of 16 participants. Now here, because you couldn't pick the same person again, order mattered. And not only did the order matter, it also was possible that it was you can't repeat the same person. So when that happens, you use this. This thing is called basic counting principle. Basic counting principle is when you're picking R things out of N things, and then you're just using that. All right. So that's one way of doing this. And you can simply do this through this method. Now, think of it like this. We can think of this second option as if I was going to pick N things. So if I were to pick N things, it will be N times N minus 1 times N minus 2 times N minus 3 and so on until I get to 1, all the numbers multiplied by themselves. And then instead of picking all of them, I'm basically taking away the rest of them. So it's like picking 3 people as winners and not picking 13 people. So all the ones that you're not picking, they basically cancel out. Okay. So when they cancel out, it's like saying that, okay, I have 16 people to choose from. So it's 16 times 15 times 14 times 13 all the way to 1 divided because we want to cancel out the 13th person, the 12th person, the 11th person, all the way to 1. All the people who did not want. And that leaves me with just the 14 stays. All of this cancels out. So it's like saying I have 16 factorial over 13 factorial. Or in other words, I have 16 factorial over 16 minus 3. The ones that I want to pick, I want to keep them. And the others I want to just cancel out. Okay. So it's like not picking 13 people and picking the 3. So leaving them there. So according to basic counting principle, there are 16 factorial ways of picking all the people and making a queue. But not picking the last 13 would simply be that I divide those out so that they kind of cancel. Okay. So that's what this is. And I can write this as n factorial over n minus r factorial if I were doing it with choosing r things out of n. And this formula, we can call it NPR, or sometimes we also call it NPR, like that. But it all means the same thing, that you are basically not picking n minus r things out of n things, and order matters. So that was permutation, that when you're picking r things out of n things, or in other words, you're not picking n minus r things. So if I want to pick, let's suppose I have 10 different electronic devices to choose from, and I just have enough space to choose 3 of them, and I'm like, okay, I want to get, this will be my first priority. I want to get a laptop as my first priority, and then my second priority is getting a good phone, and my third priority is getting a good pair of, let's say, headphones. So that order of priority, because it matters. Now if I were to choose phone over laptop, the choice will be different. And what I'm doing is I'm leaving the 7 things out of the 10 options that I have. So I can be like that now my different ways of arranging those things, or different ways of choosing or picking or making a choice of those 3 things would be 10 times 9 times 8. And why is that? Because arranging all 10 would be 10 times 9 times 8 times 7 times all the way to 1 divided by not picking 7, which is 7 times 6 times 5 times 4 times all the way to 1. And when that cancels out, I'm left with just this. Let me show you. So 10 times 9 times 8 times all the way to So 7, 6, 5, 4, 3, 1. And then because I just want to pick, I don't want to pick the last 7. I'll be like, okay, 7 times 6 times 5 times 4 times all the way to 1. And this cancels out with this whole thing. So I'm left with just this. And this is permutation without repetition, or permutation where you're choosing just a number of things from a whole pool of or whole array of things that you have. Okay, so here's the thing. Let's suppose I just had to pick 3 things, and once I've chosen them, then if I were to choose, let's say, a phone and a laptop and an AirPods compared to an AirPods and a phone or a laptop, or maybe an AirPods and a laptop and a phone, if that was my order of priority, it will still be the same. If I'm just about if the problem is just about picking 3 things out of all the 10 things that you have, then if somebody chooses laptop, phone, and AirPods compared to somebody choosing laptop, AirPods, and phone, both of them are basically going out with the same things, right? So there's a lot of repetition happening. Exactly how much repetition happening? R factorial times repetition happening. So if you're picking R things out of N things, and the order suddenly stops to matter, order doesn't matter, it all matters is what you have at the end, then you have basically R factorial things that are being repeated. So it's like saying how many ways of picking 3 letters out of 4, A, B, C, D, and I just want to pick 2 out of them, then choosing 2 would be A, B, or A, or maybe AC or AD. That's one option. Another would be AC. Okay, that's done. We could be like BA, BC, or BD, or we could also be like, okay, I have CD or CB or CA. Okay, and then obviously there'll be DA or DB or DC. Now, if the order did not matter, if the order mattered, then let's say AB will be very different from BA, right? But if order did not matter, then they're basically the same. So they're just 1. So that's 1. We'll count it as 1. Similarly, AC and CA are 1. So let me just cancel out the doubles. If the order stops to matter, then we are going to cancel out the doubles. Right now, how many options do we have? We have 12 options, right? But the moment I say that order doesn't matter, let's see how much we have. We have AC is same as CA or BA, and then AD is same as DA. Similarly, BC is same as CB, and BD is same as DB, and CD is same as DC. So how many things do I have left with? 1, 2, 3, 4, 5, 6. I'm left with 6. Earlier on, I had 12. But now, because I said that the order doesn't matter, I have repetitions here. And these repetitions are what reduces my number of options, right? How much does it reduce it with? It's just like we did over here, that I had n things to rearrange. So over here in this example of 4 letters, I basically had to arrange 4 different things. So there were 4 times 3 times 2 times 1 different ways of doing that. And when I said order matters, then I was saying, okay, I'm going to pick 2. I'm not going to pick 2. So those 2 will cancel out. So that means there are 24 different ways of picking or arranging 4 things. But because I only had to choose 2 out of them, that number was divided by 2 factorial. Why? Because 2 were the ones that I was not picking. Now, I'm further saying that because order doesn't matter anymore, I'm going to get 1 over 2 times 1 repetitions again, just like this thing. So this is like saying, okay, I had n things that I was changing. Out of that, I did not pick n minus r. Okay, good. That's permutation. Order matters. But if suddenly the order stops to matter, then you have 1 over r factorial repetitions. There are r factorial things that you will have to reduce it with so that you don't have any repetitions. Okay? And so this whole thing, it's called, I can write it like this, n factorial over n minus r factorial, things that you don't pick up, and r factorial, things that actually repeat. So that's called NCR. NCR. People write it as NCR as well. Sometimes we also write it with big brackets like this, N and R. Okay. So in your exam, they're going to prefer NCR, this one, not this one, but it doesn't matter. You can choose any one of them. These are all for the same. And remember, order doesn't matter here. Order doesn't matter. How do we know it doesn't matter? Because this OR thing tells me that I'm canceling out the repetitions. The last case is when I have combinations and I'm allowed to repeat stuff. So I'll give an example that I found online. They're saying there are 5 flavors of ice cream. There's chocolate, lemon, strawberry, vanilla, and let's say tutti frutti. And you're allowed to take just 3 of them. Okay. So how many different ways you can pick ice cream? So you could be like, okay, I just want all 3 of them to be chocolate. You could be like that I want 1 lemon, 1 chocolate, and 1 vanilla. Or you want 2 vanilla and 1 banana. Something like that. Basically, you have 5 things and you're picking 3 out of them. But you're actually allowed to repeat. And this is the most difficult of the cases that we have. So in that case, what matters is that you are picking 3 things out of 5 different things. And you can pick any number of those things. Okay? So in this case, your number is actually this. It's R plus N minus 1 over R. This is your answer. Which is pretty weird if you actually ask me. It's like you want to pick 3 things out of 5 things, you have 7C 3 different ways. Which actually makes no sense. But let's break it down. Let's say you are instructing the person who's giving you the ice cream and they are going to do exactly what you say. So you're like, okay, I have 5 things there. Let me just rearrange them. So I have 5 things and these are the 5 things that we have. There's this array of vanilla, or there's these flavors of ice cream. So banana, chocolate, lemon, I don't know, what's else? You could have strawberry and vanilla. So these 5. So let's suppose you want to have just 3 chocolate. So wo banda yahan pe khada hai. How do you tell them to pick this up? You're like, okay, go here, go 1 step forward, pick a scoop, pick another scoop, pick another scoop, move again, move again, move again, hand it to me. That's one, right? So this way you have asked them for chocolate, chocolate, chocolate. Another way could be, okay, you're like, no, hold on. You're standing here. I want chocolate, lemon, and strawberry. So move on, give me 1, 2, actually move, then give me lemon, then move, then give me strawberry, then move, don't pick vanilla, and move out. Pick any combination. Maybe you're like, I want 2 strawberries and 1 lemon. So you're like, move, move, pick a lemon, move, 2 strawberries, move, hand me up. In each of these examples, if they don't actually hand you up, before they hand you up, hand these to you, what do you see? It's basically 3 circles in each of them and 4 arrows in each of them. It's like we are picking 3 things and we're missing 4 things. Whenever you're allowed to repeat, this is what you're doing. You had 5 things. You're picking 3 things and you're missing 4 things. Here you're picking 3 things, you're missing 4 things. Right? When you make a choice not to take that, move on, that's missing on it. So basically, how many different ways do you have total? How many total things do you have? You have, just by this notation, you have 4 arrows and 3 circles. And you're just rearranging them. 4 arrows kidhar aane or 3 circles kidhar aane. That's all you're doing. So basically, it's like you have 4 plus 3 different ways of arranging them, which is nothing but 5 minus 1 plus 3, C, and you're just picking 3 out of them. And that means you have what? 35 different ways of picking 3 things out of 5 things if you're allowed repetition. And this is the most difficult of the problems that might ever come. In fact, I don't expect them to give any of these problems in O-level advanced. We do have some questions from A levels where they give you questions like these, but I haven't seen any question like this in O-levels. Okay. So those are the 4 cases where you have to arrange stuff. And so it all depends on whether you're allowed to repeat or not. So there's the basic counting principle. Then you're picking R things out of N, which means you're not picking N minus R. So you pick N factorial divided by things you're not picking. Just like that, when you have combinations where order doesn't matter, then you have R factorial repetitions that you have to cancel out. So you divide by that. So that's NCR. And when you're allowed to repeat stuff in combination where the order doesn't matter, then obviously this is a technique that I've given to you. Okay. So it's again the slot method, except you have to figure out what exactly is when are you making a choice. Not picking a thing is also a choice. So that's the concept of permutation combination. Now let's do some problem questions और होपफुली आपको समझ आ जाएगा कि क्वेश्चन कैसे आते हैं और उनको टैकल कैसे. The digits of the number 1, 2, 2, 3, 6, 7, 8 can be rearranged to give many different 7-digit numbers. So how many digits do we have? We have 7 digits. So if there are no restrictions, okay, so no restrictions, that means you can arrange them any way you want. Okay, but obviously you're only allowed to pick from these. So how many different ways do you have? You have 7 factorial ways. Why? You have 7 things. That means you have 7 slots. 1, 2, 3, 4, 5, all the way to 7. And you have 7 slots and you just have to pick them up. So you're like, okay, I'll put 8 here and then I'll put 7 here, or I'll put 1 here, or both the 2's together, or something like that. Basically, you have 7 factorial ways of doing this. So ये हमारे पास 7 factorial. Now, let's say they're saying digits 1, 3, and 7 are next to each other. Digits 1, 3, and 7 are next to each other. Okay, so you want 1, 3, and 7 to be together. So think of it like this. We want to arrange now 1, 3, and 7 together. So that's one block of 1, 3, 7. So this will have just 1, 3, 7 in it. It can be 3, 1, 7. It can be 7, 1, 3 or something like that. So how many ways of filling things here? 3, 2, and 1. Why? In the first block, I have 3 different numbers I can choose from. 1, 3, or 7. In the second block, once I've picked 1, मेरे पास 2 ही options बचती हैं. अगर मैंने 1 pick कर लिए तो I have 2 or 7 to choose from. अगर मैंने 7 pick कर लिया मेरे पास 3 और 1 है choose करने के लिए. अगर मैंने 1 pick कर लिया मेरे पास 7 और 3 है choose करने के लिए. So I have 2 different options, okay, to choose from. So this is 3 factorial when I want to pick them up. So I have 3 factorial, 3 different ways of arranging 1, 3, and 7. Okay, so that's one block. And I want them to get together. Now, if I take those out, how many numbers am I left with? We are left with 2, 2, 3, 6, 2, 2, 6, 6, and 8. 2, 2, 6, and 8. That makes 4. So 3 को हमने इकट्ठा कर लिए और उनका एक block बना लिया. Let me just call it the A block. And now I have to arrange 2, 2, 6, 8, and that block A, right? So I basically have 5 different things to arrange anywhere I want, because ये block अभी इकट्ठा ही आएगा जहाँ पे भी आएगा. So that means I have 5 different things to choose from. So that's 5 factorial. But because ये दोनों repeat हो रहे हैं, so it's going to be 2 factorial to cancel out the repetitions. Because 2 repeat हो रहे हैं, तो उससे मैं cancel out करूँगा. And I'll multiply it with 3 factorial, the arrangements inside this block A. So think of it like this. अब मेरी slots कैसे बन रही हैं? I have 5 slots, and in any one of them, I have further 3 slots. और ये कभी उठ के इधर आ जाता है, कभी उठ के यहाँ पे आ जाता है, कभी उठ के यहाँ पे कहीं पे भी जा सकता है. But it's going to remain together, and inside it, there is going to be 3 factorial, and that's my option when I have 1, 3, and 7 next to each other. Next, it's saying these 7-digit numbers are even. अब मेरे पास वही 7-digit number है. What are even numbers? Even numbers are where you have the last digit as even. So that means I can't put 1 here, I can't put 3 here, I can't put 7 here. I can just put 2, 2, 6, or 8. So I have 4 different ways of filling this up. Why am I saying 4 different ways? Because 2 and 2, I'm counting them different. और repetition में इन पे cancel out कर दूँगा. And once I've done that, मेरे पास एक number वहाँ पे fix हो गया. For the other 6, I have 6 factorial ways of arranging them. So 6 factorial because I'm arranging those. 4 ways because I'm arranging the even number on the last digit. And 2 factorial repetitions to cancel out. And that's my answer for part 3. What was different in this one and many other questions that we get is that here we were picking everything that was for us to pick from. But what if we have to make a selection? Then we have to refer to combinations, permutations, those kind of things. So let's see. A committee of 5 people is to be chosen from 6 men and 4 women. So you have 10 people, 6 of them men, 4 of them women, and you're going to choose 5 of them. So now you are not selecting all of them. You're basically cancelling out those that you're not selecting out. So अगर आप slot method से भी जाओ, so you can cancel out the ones they're not picking, or you can simply go with the permutation combination one. By the way, permutation combination के जितने सवाल हैं basic counting principle से solve हो जाते हैं, but it's going to be a little complicated for you to figure that out just by using basic counting principle. So it's always preferred कि आप permutation combination को ही use करें. But once you understand कि वो क्या है, तो बड़ा आसान हो जाता है. So let's see. If there must be 3 men and 2 women, so you have 6 men to choose from, out of which you're going to choose 3, and you have 4 women to choose from, and out of which you're going to choose 2. Now, another thing, order doesn't matter here, because we are not saying कि ये president है और वो secretary है और वो एक general member है. Because if there's that, then obviously order will matter. But in this case, where you're just picking members which are all equal, order doesn't matter. So it's combination. Okay, so let's see. You are picking 6C3. Why? You're picking 3 men out of 6 that you have. And you're also picking 2 from 4 women available. So 4 women who wanted to be a part of the committee, 2 of them you have chosen. So there are 4C, 2 different ways or different combinations of picking them. Why am I choosing C? Because there's order doesn't matter. अब आप इसको एक और तरीके से भी देख सकते हो. You can be like, okay, hold on. I have 6 factorial ways of arranging all the men or picking all the men in different order, and 3 of them I'm not picking. Okay. And because I'm picking 3, there's going to be 3 factorial ways of repetitions. जो एक जैसे होंगे. Mr. A, B, and C, and Mr. C, B, and A. They're all the same. So that's 3 factorial divided. Similarly, you're like, okay, I'm picking 4 women. There's 4 factorial ways of arranging them. And I'm not picking 2. So 2 factorial ways of not picking that I want to cancel out. And because I'm picking 2, there's going to be 2 factorial repetitions I want to cancel out. So that cancels out. And this thing is nothing but 63. So even if you do it through basic counting principle, you still end up with just the same combination permutation method. So that's how you can figure out that, okay, I want to arrange people. Right. So next, how do you make a selection if there must be more men than women? Now you have multiple options. मैं उसको ऐसे कर रहा हूँ कि instead of saying 5 men, 4 women, I'm going to say, okay, men and women, I'm going to write like this. So one option is that I can pick 5 men and no women. A little unfair, but that's one option here. Or, so because it's or, I put a plus there. Or what I can do is that I can have 4 men, 1 woman, or 3 men, 2 women, or 2 men, 3 women. Wait a minute, that I can't have. Because I need more men on the team than, or on the committee than women. So these are my only possible options. So how do I do this? I have 5 men to choose from. I'll pick all of them. So 5C5 and 4C0. Or 5C4, because I'm picking 4 men out of 5, and 4C1. Or 5C3, 4C2. And there you go. 3 different ways of making the committee when men are more than women. Okay, if there must be 3 men and 2 women, and one particular woman refuses to be on the committee with one particular man, acha, ye kya scene hua? So there's one particular man and there's one woman who do not want to be on the same team. Okay, so one way to think of that is that instead of picking, okay, hold on, how many different ways of not picking them, you can simply think of the ways of actually picking them to get there. Like, we will pick that man and that woman. We will definitely do that. Okay. So if you do that, so you're like, okay, one slot is for that man. So there's only one choice of picking that man. And there's another choice of picking that woman. And there's only one choice of picking that woman. And now you have 3 other committee members that you want to choose. Right? And out of these 3, you've already picked a man. You have already picked a woman. And you want to choose 2 more men. And you want to choose 1 more woman, because you have already chosen 1 woman. So how many ways of doing this? One way of picking that particular man, one way of picking that particular woman. uh, you have four men left, right? There are, hold on, even in my previous example I was picking 6C. Now you have five men to choose from and you're picking two of them, so 5C2, and three women to choose from and you're picking one of them. So these are ways in which you definitely have those two members on the team, but you don't want that. Those are all the ways that you don't want. You don't want to make those couple of people uh, uncomfortable or anything. So you'll be like, okay, hold on. In the first part, we calculated that if there were three men and two women on the committee, there were this many methods, right? This many methods. And these are the methods that are forbidden. This is what we cannot have. So you'll be like, okay, we'll just subtract it. So 63, 4C2 minus 5C2, 3C1. That is what we cannot have. And there you go. These are all the ways in which you can actually have or form the committee when you don't have those men and women. Now, here's another thing. Another option is that that woman is there. यहाँ पे एक problem है. You are picking all the ways in which that woman is definitely on the team and that man is also definitely on the team. What if you're like, okay, that man is not on the team, but that woman is. अब आपके पास options कितनी बचती हैं? Compared to, अच्छा, आपके पास वो man है, वो woman नहीं है. तो वो सारी options आप consider करके ये answers निकाल सकते.